Unit circle. This is the unit circle, and in this video lesson we'll discuss what the unit circle is and how to create it. There will be a follow-up video that fleshes out further the points and angles on a 16-point unit circle, but I don't intend to go as deeply here in this particular video lesson. Let's do a little analysis of what a unit circle is by first breaking down the terminology. Looking at the word unit, you who are familiar with Spanish and French might notice that this first part of the word unit is like the number for one in both French and Spanish, which come from the Latin word for one, unus. So I think it makes a lot of sense that a unit circle is a circle with a radius of 1 unit in length. Now we're going to place our unit circle into a coordinate plane. We'll do it with this coordinate plane here on the left. And here is that unit circle inserted into our coordinate plane. Now we'll enlarge the view of this unit circle graphed on a coordinate plane, and this enlargement is now on the right. And taking away the grid but leaving the axes, this is what we have left. The coordinates at the right, top, left, and the bottom of the circle are shown. On the unit circle, the cosine values are x and the sine values are y. We will see how that really comes into play a little later, and especially in the next follow-up lesson. And here's the equation for the unit circle: x squared plus y squared equals 1. Let's go ahead and solve the equation for y. If we move the x squared term to the right side of the equal sign, the equation becomes y squared equals 1 minus x squared. And taking the square root of both sides of the equation, we solve for y and get y equals plus or minus the square root of quantity 1 minus x squared. And to graph, we need to enter two functions to compose the circle, the plus function and the minus or negative function. And here they are entered into the graphing calculator. And here they are now graphed with the window adjusted for a better view. The blue semicircle on top is the plus function, and the red semicircle on the bottom is the negative function. We can use the graph trace feature and evaluate points around this unit circle. We get at this point an x or cosine value of negative 0.6 and a y or sine value of 0.8. As one last bit of information, I will rewrite the x squared plus y squared equals 1 equation as cosine squared theta plus sine squared theta equals 1. This version of the unit circle equation is called the Pythagorean Identity. And using the Pythagorean Identity, if we are given the sine or cosine of any angle, we can use it to find the other number, either sine or cosine, that is missing. For example, if we were just given this cosine value of negative 0.6, we could use the Pythagorean Identity to find the sine of this angle would be either 0.8 or negative 0.8. Every point on the unit circle, like any point on a coordinate plane, including these 4 points already shown, can be identified by a coordinate pair, an x-coordinate in conjunction with a y-coordinate. And the x-coordinate of any point on the unit circle is the cosine of the angle that places that point, and the y-coordinate is the sine of that angle. A unit circle has 16 key points that are required knowledge for trigonometry and calculus students, and these are 4 of those 16 points. Let's look at angles in our unit circle. Angles are composed of 2 rays, and here are 2 rays in our unit circle, and together they compose an angle, and these rays are shown in green. This ray along the x-axis pointing to the right is defined as the initial side or initial arm of the angle, whereas this ray above is defined to be the terminal side or terminal arm of this angle. Angles are often named for the Greek letter theta, shown here near the vertex of the angle. An angle in standard position always has its initial side or initial arm along the x-axis starting from the origin, or the point 0, 0, and going to the right from there along the x-axis, whereas the terminal side or terminal arm of an angle can be anywhere in the unit circle. And here the terminal side is now located in quadrant 2 of our unit circle. These 4 points from the 16-point unit circle represent 90 degrees, which we can also call pi over 2 radians in measure. And for another of the 16 points on the unit circle, this angle with the terminal side going to the negative on the x-axis or halfway around the circle is a 180 degree angle, which is an angle measure of pi radians. Then here is the point that is 3/4 of the way around the circle, which is 270 degrees, which in radians is 3 pi over 2 radians. And finally, an angle that goes all the way around the circle, a complete revolution, measures 360 degrees, which we also can call 2 pi radians in angle measure. And here are all the 4 points labeled as to their angle measure both in degrees and in radians. These are 4 of the 16 points in a 16-point unit circle. To see how to get the other 12 points and for assistance on how to remember what all these points are, I invite the viewer to click on the link to the video on the right side of the screen here. And if you don't want to go to that other video that really explains where all these points on the 16-point unit circle come from, here's the completed 16-point unit circle. Let's briefly review what we've covered in this lesson. We talked about what the unit circle is, that it is derived from the equation x squared plus y squared equals 1. We solved for y and graphed the unit circle. We introduced the Pythagorean identity cosine squared theta plus sine squared theta equals 1. And finally, we covered and established these 4 points of the unit circle. This has been Create the Unit Circle. Thanks for viewing.